Okay, welcome to Unit 2. We're going to do 2.1, just Part A today. And it's all about like our characteristics of quadratics, right? So I know you did a little stuff with quadratics. This unit will go into a lot more detail. I'm going to skip the warm-up for now and just kind of jump right in. But what we need to know is that standard form of a quadratic is written in this form, right? It is ax squared plus bx plus c, right? Very different than standard form of a line. A and b and c are just numbers, right? So a is what we call the leading coefficient because it's the first coefficient. Then we have another coefficient for like our linear term. This is our quadratic term. And the c is a number. Actually, is a constant is the last number here. So what we have right here, we're going to graph this. So if you want to do it on your own calculators, you can follow along. You can. I'm actually going to give you. We'll just work with this one. So I already have this written down. So what I want to do is I want to find the vertex, right, by figuring out if there's a maximum minimum. So quadratics have these parabola shapes. It's going to look like this. So on my calculator, right, I've already typed it in, -1/2 x squared plus 4x plus 1. And then I'm just going to hit zoom 6. That will always give me a standard window, which was basically it'll go -10 to +10. And then -10 to +10 for my y-axis. But right there, I can see my graph. So this graph has what we call a maximum. So the vertex is a maximum because the graph kind of goes downward on both ends. So in the middle, we have like a maximum point, and that maximum point is our vertex, right? So this graph, in this case, opens down. As you can kind of see, it looks like this. It opens down. There's arrows that go here. Your graph just doesn't show arrows, but it'll go down for infinity over here and over here. And so when any graph any parabola that opens down will have a maximum, right? So the vertex is going to be a maximum. Well, actually, I say the maximum value is the y value right here, and the vertex is like the full coordinate point. Now, what's going to dictate whether or not the graph opens up or down is that value of a. So if the a value is positive or negative, will dictate kind of where it's opening. So in this case, our a value is -1/2. Remember, a from ax squared plus bx plus c. So our a value is -1/2. That's a negative number. Anytime a is negative, the graph will open down. Right? If a was positive, you get a parabola going up. And that's kind of a few characteristics right there. Now, if we need to find the vertex on our calculator, if we're using a TI-83 or 84, it's very similar. If using Desmos, it'll just spit it out once you kind of click over to it. But for here, because on a test you'll need the TI-83 or 84, we'll just do it that way. So the first thing I'm going to do is hit second. And then what I'm going to do is go to this trace button. So second trace brings us to the calculate menu. And what we want to do is figure out the maximum because there is a maximum as the vertex. So we're going to hit 4 for maximum. And then the first question my graphing calculator asked me is left bound. So I want to go left bound. I want to go to the left of the vertex, which I'm already to the left of the vertex. So I can hit enter anywhere. And then it's going to ask me right bound. So now I need to scroll over until I go to the right part, like anywhere to the right of the vertex, which I'm clearly to the right. And then I hit enter. It says guess. Just hit enter again when you see that. And then boom, right there, 4.00, and it's 4. Sometimes your calculator thinks too hard. It's 4, 9. So the vertex would be 4. Oh, that's yellow. That's tough. Okay. The vertex we write as a coordinate point, so you do need a parenthesis. 4, 9, just like that, right? And that would be it. Now, if we ask for the maximum value, it would just be 9 because that is the highest y value that my parabola will ever reach. We don't worry about the 4, right? Now, when we think about an axis of symmetry, you probably heard that term before. Maybe, maybe not. It's basically like the vertical line which would divide my parabola in half. So like if I had to do a vertical line right there, it would split my parabola directly in half. So we need to write that axis of symmetry just like we would write a line. And any vertical line is always going to be written as x equals something. In this case, it's 4. It's the same thing as the x coordinate of the vertex, right? Because our vertex was 4, 9. So x equals 4 would definitely be our axis of symmetry. If we wanted to figure out algebraically, it's always going to be -b divided by 2a. So again, like if our equation is this, Negative b would be negative 4 over 2 times a, right? 2 times negative 1/2 is negative 1. So you'd get 4. So you get x equals 4. So that's how you can find it algebraically, which we'll get into this unit. The y-intercept, yet another characteristic of a quadratic, right? So basically, where does it cross my y-axis? Very easy to figure it out. Actually, basically, you find a y-intercept by plugging in 0 for x, because anywhere on this line, the x value is always 0. So you can see if I plug in 0 for x, this part becomes 0, this part becomes 0. I'm just left with 1. So the y-intercept, right, at x equals 0, it's going to be, the y-intercept is going to be equal to 1, right? So it's just 1. If you wanted to find out on your calculator, because sometimes it's not in standard form, like the parabola is, we can hit second trace and then value, first thing on that calculate menu. And then you'll see it says x equals blank. So if it's a y-intercept, I plug in 0 for x equals, and then I'll figure out, okay, at x equals 0, y equals 1. So that's my y-intercept, right? So just a different way to do it. So type in 0 right there. And then I already said this one in standard form, just plug in 0 for x. Same thing, right? Easy enough to get it without the calculator, but like I said, sometimes it's not in standard form, so you can't really see it in the equation. Another characteristic, the x-intercepts, right? So on my graph, I have an x-intercept right there, and I have another x-intercept right there. A lot of times there's 2 of them. It's possible to have 1, and it's certainly possible to have none. But in here, right, I can find it doing 2 different ways. I'm not going to even worry about method 2. You guys can just be comfortable with the 0 method. Again, if you're on Desmos, you just hover right around it. You hover right around it, and it'll tell it. Graph and calculator, I want to hit second trace again, the same menu, calculate, and 0. A 0 is another name for an x-intercept. So if I hit 2 or scroll down to hit 0, I get the same question, left bound. So you got to focus on one x-intercept at a time. So I'm going to go to the left of this x-intercept, and then I'm going to go to the right of that x-intercept. Definitely one will be positive, one will be negative, right? And then it says guess, just hit enter. And then I can get one of them. So 0.243, right? 0.243 is one of them. And then I basically just have to repeat that whole sequence for the other 0, which is going to be all the way over here. So I'm already to the left. I can hit enter at any point. As long as I don't go to the left of this one, right? And then I need to go to the right of the 0, so which is going to be a negative y value. So I hit enter, and your calculator is going to figure out the spot in between. So 8.246. So I had like, negative 0.246, I think, and then 8.246. This says y equals 1 times e to the negative 12. Like, that's 0. That literally means 0.0000, like 11 zeros and then 1. Again, your calculator is thinking too hard. That's just 0. Don't worry about that if you see it. Right? So I had those two. Yep, negative 0.246 and then 8.246. Those would be my 2 x-intercepts. And last but not least, we have this characteristic called increasing and decreasing. So on my calculator, right, my graph, I always read graphs like I read books, right? We read from left to right. So if I start to the left as far as I can see, when I go to the right, my graph is increasing, right? Up until I hit this x value of 4. So it's increasing every single x value that's going to be less than 4. So when I say increasing, I'm going to say it's increasing when x are less than 4, right? So for this part, increasing until I hit x equals 4 right there. Now when x is greater than 4, my graph goes down, which means it's decreasing, right? It's going down from left to right. So if it's going down from left to right, it is decreasing. So that's going to be from x is greater than 4 is where it is going to decrease. And it's going to continue to decrease forever. It's never going to turn back up, right? It's always this parabola shape. So that's all of your characteristics. Oop, I forgot one, sorry. Narrow or wide. So it's also called vertically stretched or compressed. So sometimes graphs like we're kind of comparing it to like an a value of 1. So like if that a value was 1, that first leading coefficient was 1, that's really neither narrow nor wide, or not vertically stretched or compressed. But in our case, we have like a 1/2, right? So it was actually negative 1/2. Now for narrow wide, we don't care about negative. The negative just told us if it opened up or down. So we don't care about the negative. We're looking at just the actual value of A without a negative or a positive. So we'd say absolute value to just basically say that the negative doesn't matter. So if our leading coefficient is something between 0 and 1, that was what we would call wide, which in our case, that was it, right? If you think about our graph, it was negative 1/2. So that value of 0.5 is between 0 and 1. This parabola is actually wider than most parabolas, right? So this would be wide. Now, if the A value was something bigger than 1, again, ignoring the negative, right? If it was bigger than 1, then that's what we would say would be narrow. So it would be a much thinner parabola, right? It would get vertically stretched. It would be like stretched vertically. It would seem like taller. Versus this one would be like vertically compressed because it seems wider. It's like being smushed. It's like being smushed a little bit towards, it's like shorter and fatter, I guess, if you want to think of it that way. So those are a bunch of characteristics to think about, but that's all of them for the quadratic. So if you take notes on that, you'll be in good shape for the next class.